Here's another problem where we can learn a little bit about, well, what's the purpose of using quadratics and understanding some of their functions. This particular problem, we want to maximize an area. And the example we're going to look at is, I have 100 yards of fencing. Went to the store, bought 100 yards. And I want to make a rectangle with this 100 yards. Well, what shape or what kind of rectangle do I make such that the area is maximized? Well, you might be thinking, well, Willie, it doesn't matter. Make it in any shape or any rectangular shape that you want, and the area is going to be the same everywhere you go. Well, after you do a couple of these problems, you realize, that's not quite the case. The area of a rectangle that maybe it looks like this. I have one yard on one side, and this one's 48 yards. Well, let's make it 49. 49 and 1. Well, the area inside of that one may look a little different than one that's, say, 20 and 30. Remember how you find area? Length times width? Well, the area in this one is 1 times a 49. I got 49 square yards. Over here I have 20 times 30. Well, that gives me 600 square yards. It's kind of fascinating now that I use the same amount of fencing, but I have two completely different areas. Now I know if I have 100 yards of fencing, I want to maximize what's enclosed so I can have as much playground as possible. So how do I know what the correct dimensions are? Well, using a quadratic will help us figure that out. So let's try to start to think out loud a little bit and see where we can go with this. Looks like I have a length times a width. That's one component, gives me area. But I also know I have 100 yards of fencing to go all the way around it. So if I have a generic rectangle, x, let's call the width x and the length y's. So what's the perimeter of that rectangle? 2x plus 2y equals 100. That mimics this particular illustration. I want to find out of this equation another number. One number is x. I want to write this y also in terms of x. So to do that, I'm going to solve this equation for y. Well, that's 50 really. So solving an equation for y, I was given y equals negative x plus 50. So those are my two values. One value is x, and the other value is minus x plus 50. I want the product of those two numbers, my width times my length, I want the product of those two numbers to be a maximum as far as area is concerned. And area is found by multiplying length times width. So let's multiply these two numbers. X times minus x plus 50 gives me negative x squared plus 50x. Starting to look a little bit like a quadratic equation. And with all quadratics, we can find out if it has a minimum or a maximum value. Well, the number in front of the x squared is a negative 1. So that tells me that the quadratic bows downward. And therefore, the vertex is going to be at a maximum. And that's what I want to find out, is where is that maximum value at? So let's find out the vertex point of the x, minus b over 2a. And that gives me a negative 50 over a negative 2. That equals 25. So I know that one of my values has to be 25. I just got to find out what's that other value that makes it work. I can plug that 25 back into my original equation. There it is. So x equals 25. What does y equal? Solve that out. Find out that the other number, well actually I can look right here too. Minus 25 plus a 50. The other number is also a 25. So those are my two numbers guaranteed that represent the dimensions of this rectangle. If I make one width 25 and make the length 25, those two numbers are going to guarantee that I have the maximum amount of area enclosed in this rectangle. So let's look at that. What is 25? What is the area of a 25 by a 25? is 625 square yards. A little bit more than 600, a lot more than 49, and each of these three situations each use 100 yards of fencing. Not a bad way to learn how to save some money by knowing a little bit of math, or at least understanding a little bit about it.